Distinguished delegates, welcome to the International Expert Meeting on Improving Public Health by Application of Space Technology and Open Community Approach. This is a pilot meeting organized by the University of Koblenz-Landau in cooperation with the United Nations Office of Outer Space Affairs program on space applications.
This presentation will describe the history and origin of the workshop, the scope of the initiative, the time frame and the structure of the 3 years initiative, what does open source, open content and open community mean, and the agenda of the workshop and the procedure of the workshop participation. The current expert meeting at the UN campus in Bonn is based on the UNISPACE 3 Recommendation 6, Improve Public Health by Application of Space Technology. The initiative started in February 2012 at the United Nations Committee of Peaceful Use of Outer Space on a side meeting on the 8th of February 2012. The structure of the initiative has one part is the political facilitator, which are the side meetings at the United Nations Committee of Peaceful Use of Outer Space Technology, and the other pillar is the workshops, the yearly workshops with an open community approach. The first expert meeting this year at the UN campus is the first open workshop in the 3 years initiatives. It has a pilot character and is a community of practice. We're looking on two content areas, which is spatial epidemiology and spatial ecotoxicology. And the third thing is organization and optimization and capacity building of the open community approach. UNISPACE 3 recommendations contain a long list of recommendations. One of this is recommendation 6, is improving public health services by application of space technology, and recommendation 7 is implementation of an integrated global system to manage natural disaster mitigation, relief and prevention efforts. Some recommendations action teams were established. In 2001, UNOSA established Action Team 7, and in 2006 the Action Team converted to a United Nations program called UNISPACE by Resolution 6110 on the 14th of December 2006 in the United Nations General Assembly. For Action Team 6, in 2012 the Action Team was closed by the Chair Canada, and on the Committee of Peaceful Use of Outer Space in February 2012 there was a side meeting on follow-up activities of Action Team 6 for improvement of public health services by application of space technology. This led to the first expert meeting hosted by UNISPACE in Bonn as a follow-up activity of Action Team 6. The follow-up activity of Action Team 6, Improve Public Health Services by Application of Space Technology, is operating on Resolution 6671, General Assembly 12th of January 2012, Annex Item 13. It says, stress the need to look more closely into how advanced space research and exploration systems and technology could further contribute to meeting challenges including that of global climate change and to food security and global health, and endeavor to examine how the outcomes could increase the benefits in particular to the developing countries. The scope of the initiative is promoting improvements of public health by application of space technology, in detail the spatial epidemiology and the spatial ecotoxicology. This term spatial includes all aspects of space and spatial concepts to perform epidemiological or ecotoxicological investigations and predictions, namely public health geomatics and teleepidemiology. This contributes to the concept of One Health, which means a collaborative effort of multidisciplinary working to attain optimal health for people, animals, and environment. Basically, we're looking on a risk and response cycle. On the left-hand side, we identify the risk. On the right-hand side, we allocate the resources, mainly limited resources, according to this risk. And by an integrated approach, we optimize the use of available resources according to public health risks. The space technology can be helpful in many ways in this cycle. First of all, mentioned remote sensing or robust voice communication on response side, or tracking resources by a global positioning system, and so on. For spatial epidemiology, the risk and response cycle means we identify the temporal spatial risk of a disease vector, for example, a mosquito. Remote sensing can help to identify environmental conditions that trigger these vectors. On the other side, the temporal spatial map of resources can help to identify the fogging larvicides, application of mosquito nets, and public awareness strategies and capacity building programs for vector control units or social workers in a special area that is suffering from a special disease caused by a vector. For ecotoxicology, we're looking also on temporal spatial risk map for a disease or toxic exposure. On the response side, the allocation of resources and use of space technology is focusing, for example, on precision farming for tailored application of pesticides. This includes also low-cost precision farming approaches for tailored application of pesticides that can be used in developing countries just by using smartphone technology that accesses risk mappings for a special area of agricultural production. There are two sides for the benefits. One is the economic side of pesticides reduction. The other benefit is the public health benefit by minimizing the exposure to pesticides for farm workers and people living in that area. The time frame for the Action Team 6 follow-up initiative is 3 years, starting at the Committee of Peaceful Use of Outer Space Technology in February 2012 with the site meeting, and will end in February 2015 with a milestone as a final report into the Committee of Peaceful Use of Outer Space with a definition of the next step after this 3 years' time. So we have three options at the end of the initiative, which is closing the initiative, prolong the initiative for 2 more years, or integrate the initiative in other UN programs or initiatives or UN bodies. The structure of the AT6-Follow-Up initiatives has two main pillars, as mentioned in the beginning. The political facilitator, which is a side meeting of the initiative at the UN OSA Committee of Peaceful Outer Space, which is a yearly event in February, where the participants have to be appointed as a delegate by the member states, especially for multinational public health activities. A support and guiding framework of national public health activity is necessary. Furthermore, this side meeting provides recommendation for the community of practice, which is the second pillar. The community of practice is responsible for annual workshops and expert meetings where a wider target audience for knowledge sharing, development and implementation is addressed for promoting teleepidemiology, ecotoxicology, which applies space technology for improving public health. The workshop title includes the term open community approach and improving public health by application of space technology, a concept for capacity building. You might have heard about open source software like OpenOffice, LibreOffice, which is a free office suite, really available, and the community can change the source code of the software and change it according to their needs. Open content, a prominent example is Wikipedia. The Wikipedia content can be changed by the community, can be improved by the community, new articles can be added. If we apply this on spatial ecotoxicology and epidemiology, the open source software is GIS software like GRASS or Quantum GIS. On the open content side, we have e-learning courses for spatial epidemiology, and both are products. One is open source product and one is a content product. For an open community, utilizes open source software on one side and open content on the other side, and the product of an open community in our case is improved public health by application of space technology. First, we define open community approach. Open community is a generalization of the concept of open source to other collaborative effort. The term open for an open community refers to the opportunity for anyone to join and contribute to the collaborative effort. The direction and the goals are determined collaboratively by all members of the community. The resulting work, the product, is made available under a free license so that other communities can adapt and build on them. In this context, the product of an open community is an improved public health by application of space technology. The open community approach provides a networking hub for improvement of public health services by application of space technology. And the community is operating on a giant depot of resources, open source resources and open content resources to reach the objective of improvement of public health services. How does this work for the member states? You have a joint depot of resources to accomplish the Action Team 6 objectives, and the member states or an institute or non-governmental agency can take resources from the joint depot, they use it and improve it nationally, and return the improved resource for further use back to the joint depot. If we apply that on an example of an open content resource, we use as example a course material for spatial epidemiology that shows the application of open source geographical information system, and the language of the course is English. So a member state could take the course from the depot, translate it into English and use it nationally, and then they return the translated course in Spanish back to the joint depot of resources. And so other member states, maybe in Latin America, that have also Spanish as their main language can use that from the depot in their native language. Of course, there is some workload for translation of the original course in English into Spanish, or maybe vice versa. But later the licensing model provides a free access to the Spanish course material for all other member states. So the workload has to be added to the joint depot only once, and then it's free for all member states. If we look at it in a more generalized perspective, then you might take a resource from the joint depot and you have to add a kind of 10% workload to modify and adapt the resource to your needs, the national needs and requirements and constraints. And we put it back on the joint depot of resources. The next user might use it 100% without modification. And then another application needs additional workload, 15%, but the licensing model provides the improved resource or additional resources, added resources, to 100% free to the next user, and this user might use it without modification for the benefit without any commercial agreement. And there is, in the timeline, there's a continuous improvement of the resources according to their needs, added more value into the content, and the licensing models keeps it free for the community, and the licensing model on the other hand protects companies from taking it and selling it. So if we look on an open source community portal, which is sourceforge.net, I took an 11 hours statistical data from the January 16th, 2012. It's just 11 hours and it's an average download of all open source projects hosted by sourceforge.net, and it's just one open source portal. There were, in this 11 hours, there were about 4 million downloads of software packages, and this download is 100% free usage. On the other hand, there were about 4,000 code commits, and it's marked red because there's additional workload to do to improve the source code, add additional features, provide some debugging, and there are about 450 error reports, bug tracking. So people who identify a bug, they report it to the community. These people might not be able to correct the code, but every user can help to bug track the software and help to improve it. And there, on the other hand, there are 4,000 forum posts. They discuss new features, discuss problems, discuss workflows of the program. And so, if put that in a ratio between downloads and improvements, discussion, and error reports, there is in 1.1% which has to do with improvement, and 1.1% putting effort in the open source projects on discussion of features, and only 1.01% are bug tracking reports. So summarizing, there's only a minor percentage of workload which has to be provided by the community to improve and bug track the software, and the major part is just using the software as it is for the purpose it's designed for. As mentioned in the title, we are looking on a concept for capacity building, and putting all this open source and open content environment together, we have a learning environment which includes geographic information system, which is open source software. We have open content, course material for spatial epidemiology. We have open content as tutorials, frequently asked questions, support material, community forums, which are open for the public as well. And we need, for example, open geographic data, geodata, free sources of maps, for example, humanitarian OpenStreetMap, and so on. The learning environment operates on generated sample data that shows the basic idea of the learning and capacity building environment for improving public health by space technology. The member states can use this capacity building and learning environment for spatial epidemiology, for example, also for a productive system with real public health data which is collected in the member states, and they do spatial analysis on and do the risk mapping or do a spatial analysis on the available resources. The main benefit is that the software and the content can freely distributed at universities or schools that support or educate vector control units. Nevertheless, if there are institutions that can afford commercial software, they can do it and do the capacity building material with the commercial software. But for developing countries, there must be an alternative where they can take and use the software without any commercial contract. Due to financial crisis, Also, other member states will look on the total cost of ownership of public health response measures, and they might also use the free available resources for solving public health problems in their countries. The comments mentioned before lead to the following workshop agenda in Bonn 2012. Monday the 30th of July is the main topic is spatial epidemiology. On Tuesday 31st of July we have spatial ecotoxicology, and the third day is workshop organization, working on a report to the Committee of Peaceful Use of Outer Space Technology for 2013, and we looking on the next workshop probably held in El Salvador in 2013, so the preparations have to be worked out in a meeting, and we're looking on the joint depot of resources. What do we have so far? Where can we work on? And we do a short workshop analysis from the previous 2 days, and looking on optimization of the workshop for the next year. We're looking on open project management and networking support, and we have a meeting of the steering committee. This presentation itself is an example of a final video or screencast of a presentation and how it will be available on the network in the virtual presentation mode. Screencast videos of all presentations should be available 1 week before the expert meeting will start, so that people in a virtual presentation mode can watch the presentation prior to the expert meeting. All presentations will be available from Monday the 23rd of July 2012. During the expert meeting there will be only a presentation playback at the UN campus in Bonn with a fixed playback time and date, and these dates are distributed over the expert meeting time from Monday 30th to August the 1st, and they will be presented on data projector.
Questions and feedbacks will be possible for the presentation in a video conference at least 15 minutes after the playback of the presentation. The Flash Meeting video conference tool will be open just from the beginning of the playback of the presentation, and the author will be in the Flash Meeting just when the presentation is started.
Summary. First of all, we looked on the history, origin and the background of the workshop and expert meeting. Later we determined the scope of the initiative as a spatial ecotoxicology and spatial epidemiology. Then at the third item we looked on the time frame, the 3 years time frame, and the structure with the 2 pillars, political facilitator at the Committee of Peaceful Use of Outer Space Technology, and the community of practice at the workshop or expert meeting in per year. We explained the main approach for open source, open content and open community, which is necessary for a sustainable approach with low cost technology for improving public health by application of space technology. Then we looked on the agenda of the workshop in the rough structure, and then we looked on the procedure, how the workshop creates the presentation videos, how the forum will be used for giving feedback, ask question, posing question to the authors of the presentation, and how this will lead to a sustainable provision of capacity building videos just by providing these videos for the conference or expert meeting itself. Thank you very much, and hope to see you on the conference, virtual or in person.